Hi everyone, welcome back to another in a series of training videos from Technodyne. In an earlier video, I talked to you about generalities regarding the porosity measurement. Porosity measurement, air permeability, what have you. I gave you a definition of what porosity is. Gave you a little bit of why we even test porosity, why it's important to our production people. Today I'd like my discussion to revolve around the Bendtsen test method. Bendtsen this particular test was developed sometime in the, late 30s, early 40s. It became fairly popular in Europe, maybe some outside, maybe some Canadian areas as well. Not too popular here in the United States, but today anybody exporting, we're in a very global, let's say, marketplace today, so anybody exporting is probably going to have to at least have some general information, general knowledge of what Bendtsen test is all about. So I do apologize I don't have an instrument necessarily to show you, but to give you an idea, this is one of the original setups that Bendtsen had created. He utilized flow meters similar to the Sheffield. They were rotometer flow meters to measure the milliliters per minute that was flowing through the sample. His idea, one of the similarities, as I discussed in the earlier video, was we need a couple of things to accomplish this test measurement. One of them certainly is being able to clamp the sample in such a way that we can define the area that we're trying to measure and push the air through. The other is actually creating a differential pressure from the top side or bottom side of the sheet, one side of the sheet versus the other, and the opposite side being to atmosphere. So the way that the Bendtsen folks did that, the clamping mechanism they had was a fairly simple mechanical device that the operator would set his sample in or under, press a handle to clamp it, and now we've defined that area that we're going to capture with our pressure differential. Pressure differential was created using monostat regulators, so fairly precise in the way that they set up this differential. My description up here is similar to what the Bendtsen design was, in that they placed their sample in this area for the clamping mechanism, clamped it down, and they pressurized the lower half of the sample with their monostat, and the airflow through the sample exited, and it went to the rotometer tubes for measurement. Okay? Their original design measured samples somewhere in the area from 0 to 1,000 milliliters per minute. Now, their units were defined a little bit more, let's say, their units were specifically designed around the area that they were testing. 10 square centimeters, the aperture size that they used in their clamping mechanism, at 1.47 kilopascals pressure differential. So you have a product, you have your pressure differential, it's exiting the sample, going to your rotometer tubes, and now you have a Bendtsen measurement. Okay? The Bendtsen measurement is very, I guess I would say, quite linear, and the relationship to standard cubic centimeters per minute is pretty ideal, let's say intuitive, in that when the Bendtsen units are increasing, so isn't the flow through the sheet. So pretty intuitive to actually get an idea of what that measurement is like, or what's happening. If my measurement is going up, my sample, my web in my production is opening up. If my sample measurement is going down, my web in my sample is tightening up. As I mentioned, the original range was somewhere around 0 to 1,000. What the later models moved that, extended that up to roughly 3,000 milliliters per minute per 10 square centimeters. Now, if the Bendtsen folks had some foresight in understanding that this, let's say, configuration wouldn't meet all sample grades. So as you started getting into some sample grades that were tighter, okay, much lower flows, now your accuracy of your measurement is decreased. What they had used was a method where they increased the pressure differential top to bottom. They increased it from 1.47 to roughly 2.2 kilopascals, so that now if I've got a tighter sheet, I can still force air through there and get a reasonable number as a result. On the other side, what they did was they backed that pressure differential off from 1.47 to roughly 0.75 inches of water, millimeters of water across the sheet. And now for more open grades, if I were to utilize my, let's say, the standard or more common configuration with more open grades, I might be way off the scale. Again, my accuracy would start to get lost. But if I can reduce that pressure differential, now I can reduce the actual airflow going across that sample, and I can get a pretty decent measurement. So the critical parts of the test, again, to all these tests, we have to define the area that we're trying to, or at least capture the area that we're trying to produce this test analysis on. We have to define what that pressure differential, we have to have the means to actually maintain that pressure differential across that sample long enough so that we can at least get a stable measurement. The Bendtsen test, as I mentioned, really took off and was very popular in Europe. Today, I still see it here in the States. I'm not sure about South America, but certainly in Canada, this test is being used for particularly exporting applications, especially if we're going over into the European marketplace. So we've got the basics of the Bendtsen instrument. Again, just to give you an idea of where some of these results are coming from, as you, especially if you're new to the industry, you haven't seen some of this other instrumentation if you're here in North America. There aren't a lot of these units that are being had been purchased in laboratories, but in order to give you an idea of what this value is, where this number is coming from, hopefully I've given you a quick overview and you have some basis to compare to. All right? So I'd appreciate it. You can come back. We're going to talk more on the Sheffield test. We're going to talk a little bit more on the Fraser test. We're going to talk a little bit about the Coressa test. I've already, in an earlier video, talked about the Gurley test. Hopefully you'll come back and see us soon. All right? Have a good day. Bye.